Hello friends, welcome to Shiksharthi. In this video, we shall be discussing the basics and concepts of coordinate geometry. So let's start. Now if you have seen my earlier videos, we have already talked about 2 to 3 things as far as the basics and certain basics and the concepts of coordinate geometry are concerned. And what I am talking about is how to find out the slope of a line, talking about the conditions of collinearity, talking about how to associate tan theta with the slope, and then we talked about the section formula. So in this video, we'll be majorly focusing on writing the equation of a line using the slope concept. And for this, I just want to draw your attention. So this is the first discussion that we had done, wherein we talked about what is the slope concept, and then we associated it with a trigonometric ratio with the help of, a trigonometric ratio here refers to tan theta, and then we talked about collinearity. Then we talked about how to establish the section formula using the slope concept. Now taking this discussion forward and using this diagram. So this is the diagram wherein can I say the points, so I'm talking about point A, point G, point H and point F. All of these points are, so I'm basically talking about points A followed by G followed by H followed by F. Can I say all these points are collinear? Yes. Why? Because they lie on the same line. Yes, they are collinear because they lie on the same line, right? Now if I have to write down the equation of a line given the slope, so when I know that the slope of this line, so can I say the slope of the line segment AG would be same as the slope of the line segment GH will be the same as the slope of the line segment HF, which finally results into what? I can say that this is nothing but equal to slope of the line segment AF. This is the condition of collinearity. So as discussed, we are not establishing the condition of collinearity, which we have already discussed, but we'll be using the slope concept. And whenever you're talking about the slope concept, collinearity automatically comes into picture. You can't avoid it. Okay. Now, if I have to write down the equation of this line, once I know that all these slopes are equal. So, for example, if I want to take this, if I want to consider the triangle FGC. So if I say in triangle FGC, and we know that all these lines are parallel to each other, henceforth these would be right angles. So now can we write that, so what is slope? Slope is rate of change, as we had discussed here also. It is the rate of change of the y, which is the ordinate, versus the rate of change of abscissa. Okay, so now here can I use the same concept here? So can I say that y minus y1, which is with this rate of change, versus the rate of change of the entire, which is, so I know that in this triangle, can I say that, can I say that triangle FGC is similar to triangle, no, we are talking about FGC is similar to the triangle FHE, and thereafter I can use this concept. Now what is this concept? It is just like saying the rate of change of y for two similar triangles, which is the rate of change of, for two similar triangles of this sort. We are talking about this triangle, which is FHE, and the triangle FGC. So the rate of change of y for one triangle versus the rate of change of y for the another triangle. Now these two triangles are similar triangles, would be the same as the rate of change of their abscissas. Right? Now when I use this and I know that can I slightly change this for a better inference? Now can I change it into the slope format? So when I change it into the slope format, I'll be able to say that y minus y1 divided by x minus x1 is equal to y minus y2. divided by x minus x2, the moment we convert it into the slope format, which we have already talked about. And you know that the slope of all these line segments are equal. So it is just like saying this. So all of these would be equal in a certain sense. So when we are saying AG, so AG or AH if I talk about, and so on. So though here the slope are different, but please understand we are basically talking about AG, we are talking about AH, or we are talking about GH, or we are talking about GF, or finally we are talking about HF. Okay, so once I know this, can I say that this can be written as the same slope if I assume that this is the slope of the line? And let me assume that all these slopes are equal to m, is what I am talking about. Right? Okay. Now, once I am able to say this, so this we are basically talking about what? So this basically boils down to what? If I say y minus y1 upon x minus x1, so I am basically talking about the slope of HF is the same as talking about the slope of FG, right? Which is the same as talking about the slope of HG or FG or GA or HG or HA is what I was talking about a few minutes back. Once I'm able to say this, taking it forward, can I say y minus y1 and taking this value as m for the time being, can I say this is nothing but m times of x minus x1? So from here you get the basic format of writing the equation of a line which passes through the points x comma y and x1 comma y1. And now this you can extrapolate. Now what do I mean to say extrapolate? Between any 2 points, you can write it like this, given that any 2 points are lying on the same line. So if I have to extrapolate this, I can write it like, let's say yi minus yk is equal to m times of xi minus xk is the basic format of writing the equation of a line wherein all these points, I mean talking about any point like xi or xk, so let's say wherein I varies from 1 to n, so all these points are lying on the same line is what we are talking about. All these points like let's say I, k and so on, so let's say 1 to k are lying on the same line is what I am using here. So similarly now I can say y minus y2 is equal to m times of x minus x2, y minus y3 is equal to m times of x minus x3, and then we can form many other combinations as long as we are using any two such points lying on the same line. Okay, so this is so once we have understood that this is the basic format of writing the equation of a line which passes through 2 points. Now those 2 points are lying on the same line. Okay, now I can rejig this, I can use this, and if I put it like this, if x1 comma y1 is the origin, so let's assume that this point becomes the origin, right? In that case, this equation changes to y is equal to mx. So from here we get another form of an equation which comes out of the basic information only, the basic form of equation only, wherein y is equal to mx is the equation of a line which passes through the origin. And origin means we are talking about 0, 0, the point of intersection of the x-axis, the real x-axis and the real y-axis. So let's say this becomes the point of origin, which is 0, 0. Once I know this, is there any other way of writing the equation of a line? Yes. Can I rearrange this and can I write it in the format y is equal to mx plus y1 minus mx1? Can I write this equation like this? Of course I can. What is the objective? In few minutes you will understand what is the objective behind this. For this, I'm just drawing a very small diagram. And let us say this is the diagram that I'm trying to draw here is this. So I'm using the same, let's say this point is F, right? Now this point could be any other point that I take. Let's say I take this point as H. The point this that I'm taking here is, let's say, G, and the point finally which I'm taking here is A. and then I'm drawing lines which are parallel. So this is the x-axis itself, and the other lines I'm taking it parallel to the x-axis. This I can put it as E, this I can put it as C, and this now I can put it as B. Once I know this and the basic things I've already discussed, what is the objective now? The objective in any case here is, we know that H is, the point H is what? x1 comma y1. The point G is what? x2 comma y2. Now let us write these formulas, let us write these points once again. Now once I know that G lies on the x-axis, this point changes to, I know that there is no scope for y on the x-axis. Similarly, when H comes on the y-axis, there is no scope for x. So here x1 becomes 0 and this becomes how much? This is in any case is y1. Now let me use and substitute these values here. So can I say y becomes equal to mx plus, now m in any case I know, so when is m equal to 0? M becomes equal to 0 only on the x-axis. So now here let me specify that m is non-zero. Now when I say m is non-zero, m could be positive, either positive, or m could be negative. So in that case, what is the value of mx dash given that x1 is equal to 0? So this becomes equal to y1. So this is the another format and the most accepted format of writing the equation of a line. What is y1 here? y1 is nothing but the y-intercept. What is y-intercept? The distance of a point which lies on the y-axis, the distance of a point which lies on the y-axis from the origin is known as the y-intercept of that line, and the distance of that point which lies on the x-axis from the origin lying on the line is known as the x-intercept. So here your x-intercept, if I talk about this line, the xy intercepts which it makes, the pair here is x2 comma 0 and the next pair here is 0 comma y1, wherein y1 is your y-intercept and x2 is your x-intercept. So if you recall now, once you know what are intercepts and you have already done equations, you have done roots, you have done zeros, now you can relate the points wherein the graph of any function, whether it is a linear function or a non-linear function, the graph of any function, whenever and wherever it intersects with the real x-axis, that is not only known as the zeros, it is known as the real roots. At the same time, they are known as the intercepts, the real x-intercepts. So rearranging this, and once I know that this is the y-intercept, I can finally write it as y is equal to mx plus c, where c is nothing but a special typification given to y1, wherein c is known as the y-intercept. I hope if you go through all my videos which I have done in this specific order, you will be able to have a fair enough idea of understanding how to associate the slope concept with the section formula, with trigonometry, with equation of a line, and the equation of a line passing through the origin, or an equation of a line which does not pass through the origin. And the basic format of writing the equation comes from the slope concept only of writing the equation. If you feel that this video was really informative and it takes your learning to a level which is fantastic, please do not forget to like, share and subscribe to our channel. If you have already done so, click on the bell icon and select all so that you get regular updates from us. If you want us to do videos on some specific topics, maybe difficult ones, do not hesitate and put it in the comment section so that we can do it for you. Thank you so much. Until next we meet, goodbye.